Okay, so in this video, we're going to take a look at what we call numerical discrete data. Okay, and remember that discrete data here, we're looking at exact values. Okay, so for example, it might be the number of jelly beans eaten by each kid at a birthday party. So somebody might eat 0 jelly beans, they might eat 1 jelly bean, 3 jelly beans. Somebody else also ate 3 jelly beans. Someone ate 5 jelly beans. This is what we call a discrete data set. Okay, so a lot of the time we're looking at our counting numbers. It comes from counting for discrete data. So whole numbers. An example of something that wouldn't be discrete data is, say, people's height. Oh, let's change that pen. People's height. Okay, so we could have, let's say, 168.45 centimeters. So we're starting to go into the decimal places now. Somebody else could be 169.32 centimeters. Okay, so this is not a discrete data set. And the reason being, we kind of see that here it's very easy to get two values that are the same, right? 2 kids could both eat 3 jelly beans. That's pretty plausible. But here, it's hard for 2 people's heights to be exactly the same. We could always go into the tenths and the hundredths and the thousands of centimeters, okay, and distinguish them that tightly if we needed to. But what are we going to do with this discrete data? We're more interested now at organizing this discrete data and then plotting this discrete data. Okay, so let's have a look at the jelly bean example. So the number of jelly beans eaten by each kid at a birthday party. And we take the plot, our data set. So the first kid eats 0 jelly beans, someone else eats 3 jelly beans, someone eats 2 jelly beans, someone eats 1 jelly bean, someone else also eats 1 jelly bean, another person eating 2 jelly beans, 2 jelly beans, 3 jelly beans, and someone eats 4 jelly beans. Okay, what can we do with this discrete data set? So remember, this is what we call our discrete data set. We can organize it, and we organize discrete data sets into frequency or tally tables. So let's have our number of jelly beans, and then we have our tally, okay? And then we have our frequency. So we've kind of got 2 tables in one here. And we can have 0 jelly beans, 1 jelly bean, 2 jelly beans, 3 jelly beans, or 4 jelly beans. Okay, so let's start with the first one, the 0. So let's put a tally in there for 0. Put a tally in for 3, for 2, for 1, 2 more for 2, 1 more for 3, and 1 for 4. And we can convert these to numbers, right? We got the number 1, 2, 3, 2, and then 1 again. We've now organized this discrete data set. Okay, what can we now do with it? We can display this discrete data set, and let's display it over here on what we call a column graph or a dot plot. Okay, so we'll do both of those. So we have our axes, and down the bottom here we have the number of jelly beans. Okay, so it might be 0 jelly beans, 1, 2, 3, or 4. Okay, these down the side here. And the frequency goes up to 3, right? So we got 1 person, 2 person, or 3 people, okay? So for 0 jelly beans, we only had 1 person that ate 0 jelly beans. So we're going to put that up to the number 1, like that. And then for 1 jelly bean, we had 2 people. So that goes up to there like this. And for 2 jelly beans, we had 3 people, like that. And for 3 jelly beans, we had 2 people. And for 4 jelly beans, we had only 1 person. And what we've got here, we can kind of draw a bit of a curve over this, okay? Kind of something that loops it together. And we'll look at this in a bit more detail later. But we can start looking at the shape of the data that's formed, okay? But it's important to be sort of aware just at the moment of this curve that we can put over the top. Let's do the same thing, but as a dot plot. Okay, it's a very similar sort of exercise. The graph looks almost identical, but now instead of doing bars, we're going to do little dots. So at 0, we have 1 dot there. And at 1, we have 2 dots. 2 dots. 2, we have 1, 2, 3 dots. Like that. 3, we have 2 dots. And 4, we only have 1 dot. Okay, so we kind of get something that looks like this. And these dots here represent how many for each column. Okay, so if we looked at that graphically, we can see that the number of people that ate 2 jelly beans is 3 because there's 3 dots. Okay, that's pretty much how we can organize and display this discrete data. But what if we have lots of discrete data? So for example, we go into a shop and we ask everybody what their age is. So the ages. So ages, that's terrible. Ages of people in a shop. And this is the data set that we get. Okay, so we ask the first person, they're a baby, they're only 1. Okay, 41 years old next, 13 years old, 27 years old, 37 years old, 49 years old, 11. Okay, and I'm just going to keep putting these numbers in, so bear with me. 51 years old, 43, 29, 56, 34, 31, 65, and need a little bit more room, 32 and 36. We've now got a lot of discrete data, and not a lot of these match, really. Okay, so what we do is we introduce this idea of class intervals, and we've seen these hopefully before in year 8. And what we do is rather than taking each one individually, we're just going to sort of take a range. So it kind of looks, it's better done in an example. So this is our class interval, and this is our tally. And then we can convert those to frequencies later. So rather than looking at each one individually, let's sort of group them together. So let's look at ages 1 to 9, and then the ages 10 to 19, and then the ages 20 to 29, and then 30 to 39, 40 to 49, 50 to 59, and 60 to 69. And let's extend that table down. So each one of these class intervals has what we call a width of 10. Okay, so each one has a width of 10. And now let's do a tally. Well, taking the first one here, the number 1, that falls into this class interval. 41 goes into here. 13 goes into there. 27, 37, 49, 11, 28, 51, 43, 29, 56, 34, 31, 65, 32, and 36 again. Okay, and we can convert these tallies into frequencies. So we get 1, 2, 3, 5, 3, 2, and 1 again. Well, we can now plot this, as we did before, onto our column graph, or if we wanted to do it as a dot plot, we could do it as a dot plot. And I'm going to need more room on my x-axis, aren't I? Let's draw more room out that way. Well, our frequency only goes as high as 5. So 1, 2, 3, 4, 5. Remember, this is the frequency. And down here, we have our class interval. Remember, this is the ages of people. So we have 1 to 9, we have 10 to 19, we have 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. Well, the number of people we have in the 1 to 9 column is just 1. So we draw our column like that. 10 to 19, we have 2. 20 to 29, we have 3. 30 to 39, we have 5, so all the way up to there. 40 to 49, we have 3. 50 to 59, we have 2. So it's a little bit smaller, yep. And 60 to 69, we have 1. And this, again, it's important to sort of just be aware that we can put a bit of a curve over this, okay, that looks something like that. And we come into that in a lot more detail later, okay, but just be aware that it's there. And you can also be aware that we kind of see a bit of symmetry here, okay, which we'll touch on later in lesson, I think it's lesson 3 as well, okay. Now, the last point that I want to make is about what we call the modal values. And remember, the mode is what occurs the most. So up here, it was, and I'll do it in a yellow highlighter, it was this one that occurs the most. So most jelly beans that were eaten by people, it was most common that people would eat 2 jelly beans, is what I'm trying to get at there, with a modal 3. Okay, so most people only ate 2 jelly beans. That was most common, and there were 3 people that did so. Over here, the most common age fell in the bracket between 30 and 39, and we had 5 people that did so. And we call this the modal class interval. And the modal class interval here is 30 to 39. The modal value, because remember we're not doing class intervals here, the modal value here is equal to 2. Okay, so that's it on discrete data, the ways that we can organize this stuff together and then display it, okay, on a graph.